On hand, we have Darren Bryant. Darren Bryant is our senior application engineer. He does demonstrations, he does training. He's been doing CAM for most of his life. He's one of the best machinists that I know of, and has quite a bit of experience with probing. And then we also have Greg Shills. Greg Shills is kind of one of our post-processor gurus. One of the things that sets SolidCAM apart a little bit is that we don't just say that we have a post that fits your machine, because that's a bunch of nonsense. Every machine is slightly different, or every person's preferences are slightly different. So we have a rather large team that does post-processors. And even for a Haas machine, we still find that the customers, they want it tweaked. So it does exactly what they want it to do when they want it to do it, and they don't want to have to stand at the machine making edits. So I will say that I'm not sure if you guys are SolidCAM customers already, but if you're not, this one is going to focus solely on the SolidCAM Solid Probe module. It runs right inside SolidWorks. It runs right inside Inventor, and it is a fully integrated system. And the whole idea is to allow you to be able to use that probe that may be sitting on the shelf gathering dust the same way that our customers do, and to make it as part of the manufacturing process. So it seems like we have a very good crowd today. I want to thank each and every one of you for joining us. And, I've introduced Darren and I've introduced Greg. My name is Sean. I'm the COO of SolidCAM. Just suffice to say that, I'm the guy who sweeps up when everybody's done. But, again, with SolidCAM, each and every one of the guys is a machinist first. We don't have keyboard jockeys. These are guys who actually do machining. We have a little bit of a treat for you in that we have a video that is fresh off the presses. And for all the stuff that we tell you, it'd be nice if you believed us. It would be great. But coming from a customer, I think, is probably a lot more credible. So we actually had one of our customers volunteered to shoot a video with us. And so that's what we're going to start with today. We're going to show you a video.
Just with a few clicks of the mouse, add in this nice, beautiful macro that automatically stacks in front of our CNC code and basically runs everything automatically. The probe software takes over, and we can just run the part over and over again. We decided to use the SolidCAM Probe software largely because we needed to refine our operations in our single job setups, where we have possibly anywhere from 10 to 50 part run, and we don't want to commit a new fixture to this particular part job to cut down on cost and basically keep the efficiency up. So the probe software really filled that niche void for us, because we were able to bring in the probe, have it find the part fast, efficiently, and keep our cycle times up without basically compromising anything. We already had the probe, it already existed in our machine, and we were able to just with a few clicks of the mouse, add in this nice, beautiful macro that automatically stacks in front of our CNC code and basically runs everything automatically. The probe software takes over, and we can just run the part over and over again. Let me show you how easy it is to add a probe operation into SolidCAM. So here we're going to right click into our feature tree. We're going to add an operation right up here, add probe operation. So from there, when you first open it up, it's going to default to single point. This is what we want. Before I continue, I'm going to select a tool, which is already built into my tool crib. I just select it, add it. Now if I go back to geometry, from here I can go to the Create New Feature tab. We're going to go ahead and select that, and then anywhere on the surface, according to where my origin is, center of the circle, center of the part, up to the surface of the part, and I can select anywhere on this surface. These holes are not yet there, so I'll have to avoid them, but just if I just want to pick in the middle, it's going to drop that point right there. And then from here all I have to do is save and calculate, and then to simulate, we're going to see it come down and touch right where I click. Done. So once we've finished our single Z point, and I want to go ahead and add my second probe operation, which will be in this pocket, instead of exiting out, which you could do, and restarting that process all over again, we can just simply copy, and see how it brings in another toolpath right there. And the important thing is to change your feature to, in this case we're going to change to a hole, and then from here I'm going to select new geometry, which is going to be in this pocket. So I will select the outer edge of that pocket, and then in here under technologies I want to change it, for my preference, 4 touch locations, so forward, back, left, right. And then if I want to readjust the level that the probe is going to go down into the pocket, I can just simply just come in here anywhere on the face, and just select either high or low, and you can just change it right there. That's about where I want it. Go ahead and prove that. Save and calculate, and we can go ahead and show that right there, show that toolpath, and then simulate it in Solid Verify. And this will duplicate what we will see in the machine. And you can see that it leaves a little witness mark right there in the part. Basically shows you exactly where the probe, that center of that ball is going to touch, and that's extremely helpful just to make sure that you have everything exactly where you want it. And from there, that's it. That's as easy as it is to add a probe into your program. If you add the probe in after you start your toolpaths, you will have to drag them to the top, but other than that, it can't be any easier to add in this type of automation into your CNC program. I can walk you through basically a manual process that you can use the existing probe on your machine to accomplish touching off on a part, and then we can maybe show you basically what SolidCAM turns that into. So right here we have a good example of one of our parts. When we make our parts, we have customers order these parts in sizes of basically 25 thou increments sometimes. So to have a fixture to fit all of our parts on the inner diameter and the outer diameter is somewhat challenging. So sometimes when we get specialty orders for unique sizes, we will resort to using a automatic 3-jaw chuck, which naturally doesn't carry a real good repeatability in the X and the Y. So we love to use probing to help us maximize our cycle of the part, and I'll just basically walk you through what it used to basically take for us to set up a part. So once I found approximately the center of the part and I get to the depth that I want, I'm going to go ahead and close the doors. Now after we have the probe aligned inside of our bore, I'm going to come up here into the G54, and we're going to make sure that we select the toolpath that we want for the probe. In this case it's going to be 1, which is bore. And then I'm going to come over and I'm going to put in the approximate diameter, which in this case is 1.15 inches. And once I put that in, I don't need to do any additional adjustments. I'm not going to, my datum isn't any distance away from it. Our center is the bore. So we're going to leave that alone. Now I'm going to cycle start the part, and I'll show you the probe. So now that we have the probe set up to find the inside of the cylinder, we're going to go ahead and now run the program. And that final beep indicates that the data is saved into G54 for X and Y. Now all we have left to do is to find the Z. Now we're going to move our probe out of the pocket and over onto right above the top of the plane of the part. And then we're going to record the Z using a single surface. So now we're just going to go back here, we're going to do a single surface. Come over, we're only going to travel in the Z distance. So I will tell it to go roughly 200 thou, and then we'll go cycle start. So now that we showed you how to manually operate the probe on the machine, we have our SolidCAM program loaded in, and we're going to show how much faster it is. The SolidCAM Renishaw probe integration software through SolidCAM was absolutely painless. It was really fluid. It worked really well out of the box. I couldn't ask for anything more. Training support have been fantastic. This module is so well put together, we rarely have to call support. But when we have, they have been fantastic, and the support is always there, instant as always. The ROI on this particular package has been fantastic. I would say after our second job that we used it, it more than paid for itself. We saved minutes per cycle. It really is needed for any shop that has a probe. You should be using SolidCAM's probe module.
And Renishaw would mirror those comments even on their website. They say it can reduce setup times by up to 10% or 10 times faster.
So, of course, you can set the home position on your CNC machine, as we basically showed. But you can also do on-machine verification. And my former life, I worked for Faro Technologies for portable CMMs and laser trackers and things like that. I can tell you that on-machine verification was a huge industry on itself. And in that case, they were trying to use outside measurement devices, to actually measure the part on the machine. So we're going to talk a little bit about that. And then we'll also talk about just, the measurement probe cycles that you can incorporate into your program. So setting the home position on your machine, as you just saw, it's pretty simple. And especially if you don't have a repeatable, is there such a thing as a repeatable mount? Some people would argue that. But, for most people, this will save you a tremendous amount of time. And you're going to have far better accuracy, and it's going to save you, just a ton of money. And you can manage multiple datums for separate processes. And basically what you can do is, within your machining operations, you can define a home, do several of the machinings, and then you can go and do additional datums. So you don't have to do it manually. So really great for when the stock is a casting, and basically redefine the home for each new piece. You know that the casting stock is never going to be exact. So very, very handy for stuff like that. Talk a little bit more about on-machine verification. If you have to take the part to a controlled, temperature room, to a CMM, something like that, just to verify it, it's not the same part. There's going to be temperature issues, and of course, you're never going to get it, manually chucked the same way. So, if you can do it while you're machining, there's huge benefits. In fact, again, it's a whole industry of selling, little portable CMMs and things like that to be able to check a part. And of course, what we're advocating is just use the machine itself in a probe. Okay, you can catch thermal drift, catch tool wear and run out. And of course, the big thing is, while it's still fixtured in the manufacturing environment, because it's the same part. So you're measuring it when you can still do something about it.
And according to Renishaw, it can reduce up to 20% of scrap.
Yeah, I would definitely agree with that. Now, what you have here is, again, we're not sure if you're SolidCAM customers or not. And if you are interested in knowing more about SolidCAM, we do live demonstrations like this all the time. Just let us know. And, you know, we'll actually show you. And again, you'll be dealing with machinists. You won't be dealing, you know, we sell primarily direct, so you're dealing with factory people who will know the challenges that you're experiencing. We also know the machines and the different, you know, variations of those machines. So, but here we have an operations list. It's running right inside SolidWorks in this particular case. So you can see how the actual measurement is just part of the machine operations. And we can use things like hole recognition and things like that to be able to program multiple things to measure.
Yeah, what I like about that is that, you know, if you get done cutting one particular part where a datum has to be taken from, it can all be done on the machine without any interaction. Once that part is cut, you can start a new probe routine, set a new coordinate system, and then go cut another part on the another piece on the part that needs to be in relationship to the one you just cut. And it's all automatic, lights out, nobody has to be at the machine.
Yeah, and I think a lot of people, you know, especially if they have Haas machines, most Haas owners seem to have a probe, and a lot of them aren't using it. We find that, you know, for various reasons. But there's a lot of people that you know, already have probes. If you don't, we can kind of help you make a decision on that too, as we're starting to have a lot of experience with probes. But this is primarily kind of SolidCAM's philosophy, is to let you do more with what you already have. In other words, that's why we run, you know, right inside your CAD system. There are major benefits to that, and especially in terms of money and learning curve and things like that. So now we're trying to let you use something you already have to make your manufacturing much faster. So as I was saying, it runs right inside SolidCAM. So you have your SolidWorks. We also run inside InventorCAM, and part of our software, we're actually a partner with Siemens NX. I don't think we have the probe functions ready for that, but I'm not sure if that's going to be something in the future. But just so you know that we are kind of agnostic when it comes to that. They take different parts of SolidCAM and they're putting it in things like Siemens NX. Okay, and you can see there's 16 solid probe cycles available. So if you're familiar at all with any CMM, these are all CMM functions. These are your standard functions. They're very straightforward. Okay, they're all graphical. You can kind of see what each one is very, very quickly. So learning curve is very, very straightforward. So, and as I mentioned before, you have your measurement options intermixed with your actual, you know, whether it's a face or whether it's a pocket or anything like that, with your regular cutting operations right inside the CAM manager. Okay. One of the other nice things is that if you've just defined a series of holes, like I said before, if you've just, you know, defined a pocket, you don't have to redefine that geometry when trying to probe it. So it's very nice so that you can use, you know, vice versa. Once you've defined the geometry in probing or cutting, you can still use that geometry set. May not sound like much, but if you're using, you know, a CAD file with just, you know, 1,000 features in it, and we do have customers doing that, having a subset of those features already picked, kind of huge. Now, this is a big thing about being integrated into the CAD system, is that once a design is changed, once, you know, parametrically you go and change something. In the demonstrations I used to do, I used to just scale the model. Once you scale the model, obviously every feature in it's going to be changed, and it would blow out every tool path that had been put in there. But SolidCAM and InventorCAM, they can actually automatically update that. So if your model changes, you're not going to have to redefine your geometry and redefine everything. What it's going to do is it's going to update your tool paths, and it's going to update the probing as well. So very, very nice system.
That works with all of our different stock options as well as configurations.
Yep. Okay. So, you know, we use different types of controllers, Fanuc, Heidenhain. If you pronounce Fanuc differently than I do, then I apologize in advance. You're doing it wrong. No, I'm just teasing. But everybody else seems to have their own their own pronunciation.
Fanic.
Exactly. So, but you know, we do the different controllers, and one of the big things, obviously, is preview and simulation. You're going to be able to see this in real time. You're going to simulate it, and boy, that can save you a ton. You know, you don't want to slam the probe, obviously, into the table, the stock. You know, that's something I would do. But, you know, the simulation is going to keep you from doing that. You're going to know if there's any collisions ahead of time.
That's not true. You're no dummy to machining.
Yeah. I'm missing a thumb, but you can't see that on the webinar. No, I'm teasing. Okay, so Renishaw Inspection Plus, all the machine controllers that support Macro B and the installation of Inspection Plus. So everything, you know, in the U.S., and we are a worldwide company, but in the U.S. it seems, you know, the vast majority is Renishaw. So everything Renishaw Inspection Plus does is the same thing we're basically supporting as well.
You know, I'm finding more and more people as I demo, and people that I train, I've been asking more people, do they use Probe? They don't, but they have them. The majority of people do have the probes, especially when they have a Haas. That's almost like an add-on that they just seem to get naturally. So
exactly.
There's a lot of them out there.
Yeah, and we hate to see stuff go to waste. You know, if our customers have it, use it.
Well, if you can reduce scrap and get setup times, you know, setups 10 times faster, and there's all kinds of benefits to this, a lot, not just a couple that we've mentioned so far.
Exactly, and if for some reason that you are an international company, or for some reason that you do have a hide-and-hide controller, they also have built-in probe cycles, so we can support that. So Siemens, built-in probe cycles, we can support that as well. So even the Fanuc with the Blum probe. So you're not locked into just using the Renishaw, although that's what we tend to talk about. Okay, so in just simplified terms, where does SolidCAM start? Where does the rest stop? SolidCAM is your machining operations and your probe operations, and this is a question that came up in a few of our other webinars. That's why we're simplifying it. The real magic is in the post-processor. So the post-processor handles both the machining and the probe input. And that's one of the reasons why we have Greg on the line here, who's going to walk us through a little bit of this, because he is one of our post-processor guys. And like I said before, one of the biggest myths in CAM is that a library post is going to work for every machine with that same, you know, of that same variation or model. And we know all too well that, and our post team knows all too well, that every machine, even if they come off the same loading dock, they might go to different resellers, so they're going to be configured differently. So we do custom post processors on just every customer, even if they're minor tweaks. But this is where it's handled, is all that data is handled in the post processor. And then
hey, Sean?
Yeah.
Sorry, I don't mean to cut you off or anything.
No, please.
Like 3 different questions, but I'm not seeing the questions. I got 3 question marks up there, and I'm wondering if you see the questions.
No, I'm not seeing them. Otherwise, yeah, I would have said something. Let's see if I can see that.
I see the question marks, but I don't actually see the actual question. I'm not quite sure why there.
I think these are from before. Yeah. Yep.
Okay.
Yeah, I think they're from before, and they were talking about it was the video issue. So. Got
it. Okay.
Okay.
Just wanted to make sure.
No, that's okay. So, so the controller probe cycles, the macro B, we can do print commands. That's pretty much, you know, how this thing works. And as you saw from the video, hopefully you saw the video, it can be just an integrated part of your standard CAM programming. Okay. I think at this point, and I'm trying to remember exactly where you came in, Greg. Was it, did I already go by it? But we should probably head over to you.
Yeah, I think so. Either way, or we can keep going through this and just do the full.
No, I'm getting bored with this. No, I'm getting bored. Show them something.
All right.
Yeah, I'm sure they're probably death by PowerPoint at this, you know, at this point. So.
Okay. Well, send me.
Yeah. Okay. So now we're going to be seeing Greg Schills.
Can you see my screen?
I can see your screen. Hopefully everybody else can as well.
All right. All right. So basically what we were talking about, you know, with what was in the video is automating through the use of our UI, these probe commands that are in the machine be part of that macro B language in the Renishaw Inspection Plus that runs in the background on the control for the probe. So we're just utilizing that better than doing it manually, and it's all geometry specific. The UI itself is really easy to use, and it takes advantage of the coordinate systems you already have when you would program. So you don't have to set new coordinate systems for your probing operations. You can take advantage of the ones that you already would have, as you would in natural programming. So in this case, I'll just start going through some of the operations here. If I was going to add a probe operation and you have the probe module licensed, it's going to come up here at the top of your list as add probe operation. And this is basically the standard UI you're going to see for everything to do with probing. The first thing you would do is you're going to come in here and pick something from your technology. You have to have an idea of what data you're going to get and how you're going to get it. So in this case, these are our single point operations. Our second level is the angle operations. Our third level would be the boss and the pocket, and then boss with the pocket. The fourth operation set is going to be cylinder, hole, and hole with a boss. And then we have our corner routines, external arc, external corner, and internal corner. In this case, a standard edge finding technique from the old school shop guys, we're going to go out and pick up the corner of the block. So I pick my technology. Next thing I want to do is I want to pick my geometry. So I'm going to come over here, and for the people that use SolidCAM, this is very similar. This is the way you'd go about doing any type of 2D work. You got to pick a chain. So we're going to come in and grab something. Now, I'm going to come over here. I'm going to pick my chain, and right there, and say OK. And I'm just defining what I want to get for the corner. And come in here, pick my tool, and you'll notice everything's integrated. Your probe tool is in your tool carousel or in your tool database. So you can just pick that. Your levels are all going to be transferred from your coordinate system, so I don't even usually go through that and explain what it is because it's all set for you already. Nothing to have to figure out here based on what you set for your MAC positions is going to come transferred through to your probing operations. So we end up in the technologies panel. When you look at this, you're going to turn the little, I don't know, IOSAR on or the visualize button here on, and you're going to see this is what we've told it to do. It doesn't look like a whole lot of anything right now because it's basically saying, well, you told me to pick that corner up. Now, if you look at the standard dialog box that we come up with, they're all very similar. These are all laid out that these dialogues, anything that's the same will be repeated the same and in the same location. So it's not very confusing as to what the options are for these probing routines. You're going to set approach retract, which is going to be the distance from the initial point over to the start point. And you can see I can scale that in and out. All these dialog boxes are middle mouse rollable or draggable. I don't know what the technical term is, but that's how I call it. So I can set my distance for the approach retract. It's going to come up with some defaults on its own, and you can roll those in and out to better approach that particular probing operation. The Z level is the same thing. You can roll it up, roll it down to wherever you need it to be. And then we're going to get to the actual meat and potatoes of this one, which is going to be the distance. Where do we want to pick on the edge? We're just going to slide these out and pick on, if we had stock there, that's what we're going to do. We're going to pick, those are going to be our probe points. Now, this is just a graphic representation of what we're going to tell the probe to do via the macros that are in the machine. So at this point, we say, go ahead and calculate. So that saved it into the memory, so now we can go in and generate our G code. Now, the probing adds all of this G code in here. Now, for those of you not familiar with G code, it's a pretty good idea, especially if you're running a probe, to have at least some idea of what these codes mean. We do everything in our power to make sure that you cannot crash these probes. That being said, we would come in and normally turn the probe on if it's not on. Then we go into what is called a protected positioning mode, which is G68. G65 P9810, which moves at a high feed rate, not at a rapid. If while you're in 9810 mode, you strike the workpiece, it will not break the probe, it will stop the machine, and it will issue an error saying unintended probe trigger. So you should be safe from everything to do with running into a clamp, or as you're traversing across the part, maybe you forgot something. You shouldn't have to, we're protecting you in that aspect. We're moving around in protected mode. We position the probe with these two lines, then we come up here and we call the actual macro cycle that's in the control that is part of the Renishaw Inspection Plus software. What this does is it's telling the probe, what's that? Did you say something, Darren?
Nope. You'd think I would, but I didn't.
Okay. All right. I thought I heard somebody thought you speak. In the background, what we're doing is it's going out and telling the probe what to do. This particular cycle, it tells it it's going to be an external corner pick. It's going to tell it what positions, if it has secondary positions, and then it's going to tell it what to do with this information. And I have a double S1 on here, which shouldn't be that way, but in this case, you would see an S1. When we're trying to find the edge of the workpiece, we're trying to set G4, our XY position. S1 denotes G54, which is in SolidCAM's terms Mac 1. If we were using Mac 2, Mac 3, Mac 4, you would see an S2, S3, S4. That is saving that XY position to S1. Now there's many different things we can do with probe. We can go out and we can set work coordinate systems. We can go out and we can interrogate features, and that's where kind of the beauty of the software comes in, is that it's not just for setting a work offset. And I'll kind of get into that as we go through some of these other routines on what you can do with it. So for this, we've got everything, and this would be perfectly runnable at the control right now. All it's doing is going out and picking up the external corner. So now, one of the things that we showed in the video was that you can establish a secondary datum. And one of the functions of probe is, let's just say we had this block. We were going to come in and find the edge. Then we were going to do a machining function, and then we were going to recall that and interrogate that resultant feature and set another datum. Well, in this case, I already have this boss that I was machining, so I would drag this one down underneath, or maybe not. It's not going to let me drag it. There we go. So now I ordered my probing operation. I put the probe first, then I did this machining function. Now let's say I'm going to use that information or that feature for something else. So now I'd come back in here, and I would say add probe operation, and I would say I'm going to interrogate the cylinder. And for this one, I want that information to be recorded in Mac 2 position 1, because I'm going to use that information from G55 to machine the rest of this block. So I'm establishing a new datum. So I would come in here and I would grab this and grab the feature, which is that contour, and say OK. And grab the tool. And then come right down to the technologies, and you can see that that's turned on that particular technology. And I'm going to drop this in there like such and locate my Z position. And you can see the dialog box pretty much stays the same. As if you play with the interface, you'll see that everything that was repeatable we kept in the same locations, and then the new stuff kind of grows on the bottoms or on the end. So in this case, we have the ability to pick 3 points, touch points, or 4 touch points. The software will support both of these, and in this case, I'll use 3, and save and calculate, and then I can hit G-code, and you can see the appropriate probing cycle comes out. We hit our protected positioning. We'll call a 9823, which is our 3-point probe operation, and it's going to save the result into G55, which is S2. The probe does all of this on its own. Now, Are you good to go, Sean, or you want me to stop talking?
No, I think we'll go back. And let me just say that every seat comes with training. And the training that we do is either in a webinar like this or it's one-to-one, but even the one-to-one is in a GoToMeeting. So it's always explained like this. It's always explained real time. That's how SolidCAM does 99.9% of our training. If for some reason you had to have it on site, that's available as well. But what we're kind of showing you is the front of the house and the back of the house. And Greg was, showing you the interface, and then he's showing you the effect on the G-code. So front of the house, back of the house, if you're not real strong on the G-code side, that's fine, because we'll show you how to use the interface so that it's going to do exactly what you want it to do. So now we did get a couple more questions. Okay, so really fast, going back to the post processors for the probes, does it come standard to the machine, or is it something that we'd have to add into the post processor?
The probe library is an add-on to your post. It is a separate library that takes me roughly about minutes to integrate into your post processor if it's a standard post processor from us. I wrote that separately to not affect the post itself and make any changes, so it won't affect the actual reliability of the post that you're already using. So we can pretty much seamlessly integrate the library into any existing post.
Right, and then the other thing is, can you simulate the probe path? Was the other question?
Yeah, absolutely. I can finish this one, close that one up, and then just do all these and simulate.
As far as pricing goes, I would just, talk to any of our, we're all direct guys, so talk to any of our sales guys on the pricing of the probe, but it is extremely, I think it's extremely low priced. I know in other countries, they're actually splitting out the ability to find 0 points, reference points, and they're splitting out that from the metrology, being able to interrogate bore diameters and where things are. For us in the U.S., we roll it all together, and it's an extremely low-cost product for what it does. Okay.
Anything else?
Okay, let me go back and see if there's anything. Okay, so I think we're good to go on that. And yeah, I'll take it back for just a second and see if there's anything else on here. So change presenter, back to me. Okay.
Yep.
Show my screen. Okay, so. Okay, so actually supportive probe tool in all simulations. We have different types of simulations. Some are just, the wireframe simulations. Some are full graphical. So yes, it is going to show that. We do have inspection reports just in real time. Basically, you can do a print dump directly from the controller where the information is stored, so that you can get that information in real time if necessary. So it's not going to work with Minitab or work in Excel or give you a, it's really not meant as a inspection report such as you'd get from a CMM or something like that. It's really meant for kind of like action-ready data. So it's the type of data that you can use to make sure that the process is correct. But just because of the limitations of where the data is stored, it is more like just, a print output type of thing. So as part of the process. Okay, so I'm going to close with this before Greg kind of closes his, but it's not meant to replace a CMM for what we just told you. It doesn't work with Minitab. It doesn't work with, a big data dump. It's really not meant for that. This is an in-process data gatherer. So, and of course, it should not be used in lieu of first article inspection. First article inspection, oftentimes, if there's, they call it the fox guarding the hen house. And first article inspection, just coming back from my metrology days, and just so that we're honest here, is generally done with an outside or an independent measurement device. Reason being is because it's the fox guarding the hen house. If there's some issue with your machine, obviously you're not going to catch that. If you're using our measurement device, if you're using your machine as a measurement device. So we're trying to be as upfront as possible. So, and again, it does not output custom formatted data. You know, for something like that, there's a slew of programs out there, especially for on-machine verification. You know, the folks at Delcam's Power Inspect are real good. That's always been a very powerful program. Of course, you're looking at a lot of money for something like that, plus some sort of outside CMM. But this will give you, again, action-ready data. So having said that, Greg, do you want to finish up?
Sure.
Okay, so I'll change back to you. Yeah.
All right.
Fact is, it's going to extract more throughput for the machinery you already have. And if you already have a probe, you're already halfway there.
And to kind of touch on some of the things that Sean was talking about, you know, for first article inspection, you can't use it for that, but you can use it for in-process inspection. And we kind of touched off on, you know, setting datums. For anything else, the probe is going to gather a certain amount of information, and one of the flexibilities of probe is you can do an awful lot with it. You just have to understand how it works and what it's doing for you, and that's one of the things that we run into a lot, is that people don't understand. They have these probes and they don't understand what they can use them for. Oh yeah, it's just for setting a datum. I can do that manually. You can do a lot with probe. You just have to understand what's happening at every time that probe is triggered, and I'm going to cover that just a little bit. One of the things that we have built into our probing routine, and we do build these into the post-processors, is we will take this data when we go out and we're going to interrogate something. The probe itself records several different data points into what they call bubble memory. And based on the machines that you have, and I'm just popping over to the Haas manual right now, all of this information that the probe is gathering, and it's not just gathering, you know, hey, this is the X and Y coordinate for, you know, the corner of a block, and I'll show you exactly some of the other things that we can pick up. These parameters in the control, you can write things to. There are certain areas in the memory that has been set aside for you to write this information to, so you can go back before you pull the part off the machine and page through your parameters and say, oh, I want to go look at, in this case, you know, we have parameters 120 to 139 available to write this information to go back and check a bore diameter or something in relation to what the probe was set out to go do. Before we loosen up the clamps, before we take the part out, we can have the operator go out and page through and look through this information. This is the same information that Sean was talking about that we were dumping that out to the printer. As we're gathering this information, it's stored in a bubble memory. It's a one-shot only deal. When you trigger that probe, all this stuff goes in and is in the controller in a bubble memory until the next probe is next probe trigger erases it and writes that information there. What we can do in the G code is actually take this information out of the bubble memory and write it into storage locations in the actual machine memory to come back and check later. And we go about that with miscellaneous parameters. So if I would just go in and grab this particular routine and go in outside, I'm in the tech panel, and I go into the parameters panel, I can say these are all of, whenever you trigger the probe for an external routine or an external corner, all this information is written into the bubble memory. It's in the 580 range, I believe, in the machine controller. We have added the ability to take that information and store it into parameter locations. So you can use it semi-pseudo to a CMM machine, but to interrogate things based on what the probe finds and save them for use later. So if I would check this information here and G-code this out, you can see that we do the probe routine, and then we're taking these locations, which is the bubble memory, 185, 186, 190, and storing them out to another location in the memory so that I can use them later. So you have to remember that the interface to make the probe do things, the only way we can communicate with that software that's running in the background on your machine, and that's that macro B Renaissance Inspection Plus, is through the G-code. And that's how we can automate this, is because we give it a probe call. This 9816 is actually a macro in your memory on your machine, and it tells the machine what to do. So if you open it up, it's all broken down into, it's man-readable. You can look at the G-code and see what it's telling it to do. And then we can use these variables later if you take G-code to an advanced level and want to build off of these locations, off of things that you've measured, and put variable programming in it. This is how you'd go about doing that. But this is the interface to get around all that, is to store them into the upper memory locations in the control. But you may not use probe to that level, but the ability to use probe beyond setting a work offset is there. You can do an awful lot with probe, and that's where we're finding the people that have the probe sitting on, just on a shelf somewhere, and they're not even, using it beyond the manual capabilities of the machine. It's worth a look. It's worth, exploring what you can and can't do. It's an automation process. You can, set these all up to move from one position or one datum to the next with lights out machining, because it's establishing all this stuff and going out and getting that information without any user intervention at all. You program it based on your geometry, and it does all the rest for you. One of the other things that we've talked about in the past, and I have finished now too, is that we have a solution for the Marpaz probe. Marpaz is a competitor to Renishaw, but they're a very popular solution as well. So we can drive the Marpaz solution as well.
Okay.
So I don't know if there's anything else you'd like me to show, or
No, I don't think so. Are there any other questions? I don't think so. So I will say that thank you, Darren. Thank you, Greg, and most of all, thank you, folks, for your time today. And yeah, if you would like, I'll drop my email address in here. Hopefully, you can all see it. But please just give me a holler. We will be sending you a video. We actually videotape this, as well as that video link. So we'll be sending you links to that. And if we can be of any service to you, just let me know. Again, Sean.m@solidcam.com. I just put in there to the entire audience, Sean.m@solidcam.com, and we'll put you in touch with the right people. So again, really appreciate the time and attention, and the probe is really kind of a neat thing. So I hope you guys will take advantage of it, and that it helps make your process better. So thank you all.
Awesome.
Have a great day.
Have a great week.
Thank you, James. James Holbrook said it looks exciting. Appreciate that very much. So take care.
Take it easy, guys.
Bye-bye.